Hello all, I am Pavan pursuing my MS at Center for IT in Building Sciences, IIIT Hyderabad, Telangana, India. Today I am going to present my research paper about the investigation on air conditioning load patterns and electricity consumption of typical residential buildings in tropical wet and dry climate in India. This presentation is divided into several sections such as introduction, objectives of the study, method, the several types of analysis done using the data, and the Introduction. As per the data published by CEA of India, residential sector is responsible for 24% of total energy consumption in the year 2019-20 and is expected to grow fourfold by 2030. Number of electrified homes throughout the country has increased from 55% in 2001 to 87% in 2020, and the per house energy consumption is also rising. Therefore, it is vital to understand the household energy requirement and usage patterns for a large developing country like India. Recent studies have also shown that appliance ownership, occupant behavior, thermal comfort, appliance usage period were some of the most significant contributors to energy consumption. Studies suggest that by 2037, AC consumption in India would increase by 4.3 times than in 2017 and 18. Though ACs in residences run only for a few months each year and generally during the night time, they significantly increase the energy demand during the operation time. Therefore, it is also essential to understand AC usage patterns and analyze their contribution towards to the overall load. The objectives of this study include understanding the seasonal electricity consumption trends for AC and non-AC homes, and also to understand the AC usage patterns and their impact on total energy consumption. For this study, 25 dwellings in Hyderabad were selected for survey and monitoring in the year 2019. Monthly energy bills were collected for 1 year. Current, temperature, and humidity were monitored at high sampling rate for 8 months. Data collected through the study is used for several analyses, such as monthly electricity consumption patterns is done using energy bills data. Seasonal analysis was done using 14 days of current and temperature logger data for 19 homes. Primary AC analysis was done using 19 days of current and temperature logger data from 11 homes during the summer. To give the brief introduction of the city where the study was conducted, Hyderabad occupies an area of 650 square kilometers on the Deccan Plateau in the northern part of South India. The city lies on predominantly sloping terrain with an average altitude of 542 meters above mean sea level. The city has a tropical wet and dry climate. Annual temperature averages about 26.6 degrees Celsius and monthly mean temperature ranges from 21 degrees Celsius to 33 degrees Celsius. Summers start from March and go up to June with hot and humid climatic conditions. Maximum temperatures during summer sometimes exceed 40 degrees Celsius during the April and May months. The coolest temperatures occur during the December and January, when the lowest temperature occasionally dips to 10 degrees Celsius. May is the hottest month when daily temperatures range from 26 to 39 degrees Celsius. December, the coldest, has temperatures varying from 14.5 to 28 degrees Celsius. Characteristics of homes. Majority of selected dwellings are independent units or within low-rise multi-family buildings. All the dwellings were constructed using an RCC frame structure with burnt clay bricks as infill. Windows are single glazed with fixed external shading. Average age of dwelling was around 10 years. Selected homes were then categorized into 3 income groups: low income group, middle income group, and high income group, according to the categorizations given by the PMAY scheme. The table here presents the picture of number of homes that are in each category. Monitoring devices. Continuous monitoring of household electricity and the indoor environment was performed using low-cost sensors that were developed in the research lab. Garud, a current consumption logger, recorded electric current at 1-minute interval. It consists of 3 CT clamps that can be installed on the main circuit board, having a 1-phase or a 3-phase connection. The accuracy of the Garud was tested in the lab by comparing and calibrating its results with reference devices such as Yokogawa and Wattnode power meter. The comparison showed that the Garud has 95 to 97 accuracy compared with the standard meter. Envilog, the relative humidity and temperature logger, was used to measure the indoor temperature and relative humidity at 15-minute interval. The accuracy of Envilog was compared with iButton and Hobo U12 devices. The comparison showed that Envilog has an accuracy of plus or minus 3% for relative humidity and plus or minus 0.3 degrees Celsius for temperature. Data overview. The table here gives you the picture of the data used for each several types of analysis. Mean monthly electricity bills from 25 dwellings out of which 19 AC homes and 6 non-AC homes in the year 2019. Mean monthly outdoor temperature of Hyderabad of year 2019 were used for the analysis of annual energy consumption. The seasonal analysis used Garud and Envelope data from 19 homes, out of which 15 were AC and 4 were non-AC homes, for 14 days in each season, so that is during summer, monsoon and winter. Finally, Garud and Envelope data of 19 summer days from 8 single AC and 3 multiple AC homes were considered for primary AC analysis. This paper also presents the method used for a detection of AC and identifying the true AC consumption load. The basic functionalities of AC are maintaining the set point temperature levels, dehumidification of the space, and good air circulation. An AC usage cycle is the window or the time period where the AC unit is run in order to maintain the room at set point temperature specified on the thermostat. During this cycle, the air conditioner's compressor is turned on and stays on until the room temperature drops to set point temperature. The compressor goes off after the desired set point is reached and starts again when the room temperature rises. In a single usage cycle of an AC, there will be n such instances of compressor on and compressor off time. When the thermostat is set to relatively low temperatures as compared to room temperature, the compressor would work for longer periods of time to lower the room temperature, meaning the bigger the gap between the room and set point temperatures, the longer the compressor on instance will be, and vice versa. Hence, to identify the true current consumption of AC, which is only when the compressor is on, the total current consumption needs to be identified during the compressor on time, and then we need to eliminate the non-AC current consumption from it. In the graph given here, we have highlighted 4 areas 1, 2, 3 and 4, where the highlighted area 1 and 4 is the normal load, hence the AC status there is manually marked as 0, and the area between the green parenthesis is when the room temperature drops and the current consumption shoots up, suggesting the usage of AC. Such parts of the data where the usage of AC is identified are manually marked with the value of 1000 in the AC status column, making it a binary column of manual tags 0 and 1000 in respective dwellings data files. The highlighted areas 2 and 3 show the current consumption values with compressor on as peak values and compressor off as low values. The blue here in the graph is current consumption data of total dwelling. The yellow line represents the indoor environment, indoor temperature, and the orange line here represents the manual tag that we have given. Coming to the energy bills analysis section. To understand the yearly consumption pattern for each household, electricity bills from 25 dwellings and outdoor temperature obtained from the weather data provider were collected for 1 year. The electricity consumption for each month is shown in the figure for different income groups. This figure focuses on identifying the electricity demand across all months in the Hyderabad for different income groups. An apparent increase in energy demand is visible during the March-June irrespective of the income groups. This intuitively implies the rise in usage of air conditioners during the summer months. To verify this hypothesis, the 25 dwellings were then split into AC homes and non-AC homes. This graph here gives you the mean monthly electricity usage versus outdoor temperature based on the AC ownership in the dwelling. It is observed that AC homes energy consumption increase in summer in line with the increase in outdoor temperature. Change in outdoor temperature has no significant impact on the monthly electricity consumption of non-AC dwellings. An increase in energy consumption in AC homes during summer clearly indicates the use of AC and its contribution to home energy consumption. To quantify the AC energy consumption, seasonal analysis was then performed. To understand hourly electricity consumption patterns across 3 different seasons, summer, winter and monsoon, 14 days of Garud and Envelope data were considered in each season. The 14 days selected from each season had complete data and represented the best period of the season for analysis. This table provides a clear picture of the data that is considered for the following analysis. The graph here shows the average hourly load for AC homes across summer, monsoon and in winter. In summer, an increase in the load during sleep hours, which is between 10 pm to 6 am, is evident. A short peak in load during the afternoon 2 pm to 5 pm shows the usage of air conditioners by a few households. The average energy consumption of AC homes during the summer season is 15.1 kilowatt hour per day. In monsoon and winter seasons, there is very little consumption during the sleep hours, indicating no use of air conditioners. There is a slight peak during the morning hours between 7 a.m. to 10 a.m., which may be due to electric hot water geysers and kitchen appliances. This peak is also visible during the summer but is smaller than monsoon and in winter peaks, because in monsoon and winter, besides kitchen appliances, geysers would have been used. It can also be observed that there is a rise in electricity consumption after 6 pm and drop after 10 pm, which must be the load due to lighting, television and kitchen appliances during the evenings. The average energy consumption of AC homes in monsoon is 6.6 kWh per day, and in winter it is around 6.1 kWh per day, which is less than half the average load consumed on a summer day. In the non-AC homes, there are two peaks observed in all the load curves. One is the short peak in morning hours between 7 am to 10 am, which is also seen in the AC homes for every season. And the second peak is in the night time between 7 pm to 12 am. The average energy consumption of AC homes in summer is non-AC homes in summer is 5.5 kWh per day, which is 36% of the daily average energy consumption of AC homes in summer. During monsoon, the morning peak between 7 am and 10 am indicates usage of geyser and kitchen appliances, similar to the energy consumption peak in AC homes. Patterns are identical in all the seasons. Patterns are similar in all the seasons. However, in monsoon and winter, there is more significant peak in the morning, and average load in summer is more than monsoon and winter, mostly because of fans and air coolers. AC homes consume about 33% more as compared to non-AC in monsoon and winter. This is probably due to more appliances being used in AC homes, as AC homes are generally occupied by people with higher income group. This is the table which shows the observations that are made in AC and non-AC home seasonal analysis. Primary AC analysis. Usage of an AC can have significant impact on the annual energy consumption of a household. The energy consumption of an AC is a function of set point temperature, AC efficiency, internal and external loads, and hours of usage. The objective of primary AC analysis is to understand AC usage in Hyderabad homes. We have considered primary AC as the most used AC in the home. In the case of a home having single AC, that AC was considered as primary AC, and in the case of homes with multiple ACs, the most often used AC in a bedroom has been identified by the homeowner was considered as primary AC. Data at 1 minute interval from Garud and a 15-minute interval from Envelog of 11 homes, out of which 8 single AC homes and 3 multiple AC homes out of 19 AC homes were used for this analysis during the summer season. The selection of homes was based on 100% availability of data for continuous 19 days during the hottest days from between 10th May 2019 to 20th May 2019 of the summer season. Those homes were selected that were occupied during this entire 19 days period and had properly functioning devices. The figure here represents the hourly AC runtime averaged across 11 homes. The most common AC usage window in all the homes is during sleep hours, which are generally between 10 pm to 6 am. AC use is highest during the sleep hours with an average of 5.2 hours out of 8 hours, and minimum during the daytime between 7 am to 9 pm with an average of 1 hour. The average runtime of an AC across all the homes in 19 days is 6.2 hours per day, with a minimum being 3 hours and the maximum being 8.9 hours. Conclusion. To conclude the study, this study provides information about the total electricity consumption, seasonal consumption trends for AC and non-AC homes, and AC usage patterns by collecting data from 25 dwellings in Hyderabad, a city with composite climate. Data was collected in the form of electricity bills, household surveys, and monitoring through current and temperature humidity loggers. Analysis on the collected data showed that AC's use reduced the daily average indoor temperature by 2.5 degrees Celsius compared to the non-AC homes during the summer season. Also, the daily average energy consumption of AC homes was more than double during the peak summer days when compared to monsoon and winter seasons. In the summer seasons, ACs increased the load by 5 to 6 times during night time and by 2 times during the evening time. IEA projected that by 2030, the number of ACs in India will increase to 240 million units from 27 million in 2016. This increasing demand for ACs is putting an enormous strain on the electric grid. Renewable energy, especially photovoltaic solutions, produce energy only during the daytime, but because the usage of AC is mostly during night time, managing the load is a serious concern. This study will help energy scientists and policy makers to further investigate AC consumption patterns and put forward strategies related to the efficient usage of ACs, efficient building envelope, and control and thermal storage. Thank you.